Hello, this is Algebra 1, Lesson 1 from Topic 4, Solving Systems of Equations by Graphing. In this lesson, we'll use graphs to find approximate solutions to systems of equations. Let's look at Explore and Reason. Juan and Leo were supposed to meet and drive ATVs on a trail together. Juan is late, so Leo started without him. Okay, if you look at the graph, we see some important information. The trail total is 40 miles long. Leo's speed is 12 miles per hour. Juan's speed is 15 miles per hour. Okay, so why don't we figure out, before we look at all these questions, why don't we figure out how much time do each of them take to finish the trail? Okay, in order to figure out the time for this problem, you need to know one important thing, which is that distance is equal to speed times the time. Okay, in other words, time should equal to distance divided by speed. Okay, so in order to figure out how much total time they will take for the entire trail, we can use this equation. Okay, so look at Leo's. Leo has 12 miles per hour. The whole trail is 40 miles long. So you're going to divide 40 by 12 because every hour Leo travels 12 miles. So if you multiply by 40 miles, then you will get how much total time he needs to finish the race. Okay, 40 divided by 12 is 10 over 3, which is 3 1/3 hour, or 3 hours and 20 minutes. Okay. Juan, in the same way, travels 15 miles in 1 hour. So you multiply that by 40 miles and you get 40 over 15 hour, which is simplified to 8 over 3 hour, which is 2 2/3 hour, which is 2 hours and 40 minutes. Okay, keep that in mind. Those are their speed. This is the total distance that they're traveling. They're traveling the same trail. So first, look at part A. Write an equation for Leo's distance from the starting point after writing for X hours. So now we want to write an equation for Leo. Okay, so y is the distance that he has traveled, and distance is going to change every second, every minute, right? Because he's traveling, and the distance he traveled will increase, okay, depending on his speed and how much time he traveled. So again, look at this equation. Distance is equal to speed times time. So distance, total distance is y here. Speed, Leo's speed is 12. So that's going to be our slope in the equation. Time is the x hours, because time is also going to be different. It's going to change. So time and distance will change in this equation. So we have y and x. Okay, speed stays the same. What about Juan? Write an equation for Juan's distance from the starting point if he starts h hours after Leo. So we have another variable, but that h is going to be given depending on the scenario. Okay, so for this equation, we're going to have 3 variables right now, but that h is not a variable. It's going to be a certain instance, okay, certain scenario. So y is equal to 15x, but he's gonna start later. So his distance is gonna be subtracted by how much Leo traveled first, how much time he started earlier, right? So 12 is Leo's speed times h would be the distance that Leo traveled in the hour that he started before Juan. Okay. And let's stop and think about why could the information given be represented by a linear function? Why are we using linear function? Because there is a relationship between the variables of time and distance such that any value for time can only have a single distance value. Okay, we have two variables that are changing. And for each time, you have a single distance that correspond to it. So we can have a relationship between two variables, and we can write that as a linear equation. Okay, and what does the speed represent in a linear equation? In this case, the slope of the line. In most cases, the speed will represent the slope of the line when we use linear equation. Part B, suppose h is equal to 1. How can you use graphs of the two equations to determine who finishes the trail first? Okay, so for part B, how do you use the graph? Let's go to Desmos.com. Okay, first step, you're going to graph two equations, y equals 12x. And what is our next equation? H is equal to 1. So that means we have y is equal to 12x and y is equal to 15x minus 12 times 1, which is just 12. Okay, so we have y is equal to 15x minus 12. Okay. It looks like it's parallel right now, but the graphs are gonna get narrower and they're gonna meet at some point. There's an intersection point here. You see that? But that means, you know, Leo is going slower than Juan, and Juan's gonna catch up at some point. But is he gonna catch up before 40 miles or after 40 miles? Is it gonna be enough time for him, right? So we wanna see when Leo starts 1 hour before Juan, because Juan is late. He's gonna get started. Juan is like an hour late, and then Juan starts as soon as he gets there. And what do you know? After you graph them, graphing two equations is not enough. You want to know when they finish it, right? When they finish the trail, which is 40 miles long. And the distance in this graph is represented by y. So you want to graph, you also want to graph the equation y equals 40, because that's when they finishes it, right? When you graph y equals 40, you know when you want to stop, right? If you zoom in closer, that is y equals 40 graph. And the red one is Leo's. The blue graph is Juan's. Who finishes first? Well, how do you know? X represents here the time, right? We've set the we've set the variable x to represent the number of hours, right? So after 1 hour, Juan starts, but Leo starts from 0 hour, right? So that's when they have different starting point. But who finishes first? After an hour, the smaller value of x that touches the line, the green line, will be the one who finishes first. So the red line crosses the green line first at a smaller x value, right? And the blue one comes later. So Leo finishes first when when Leo gets a head start of an hour, right? So that is your steps. First, graph two equations, and then also graph y equals 40 line. And how do you know? The line that crosses y equals 40 line with a smaller x value will be the line of who finished first. Okay. Part C, how much of a head start must Leo have to finish the trail at the same time as Juan? So he wants to know how much he wants to wait so that before Juan comes, so that they meet at the end point. They want to have the exact same intersecting point here, right? That means the trail has to be this long, but the trail is not gonna be changing. It has to be 40. So depending on the hours he waits and the hour he gets a head start will be where they might meet. So start plugging in some values. If he gets 1 hour head start, that's 12 minus 12, right? Because Leo travels 12 miles per hour. So he's already 12 miles away from Juan. What about less than that? If he waits 30 miles, if he waits 30 minutes, so that's 0.5, 1 over 2. 12 divided by 2 is 6. Okay, if he waits 30, then Juan finishes earlier. Do you see that? Juan finishes a lot earlier. So he wants to wait between 30 and an hour. What about, you can try guessing, try guessing and check, but there is an algebraic way to solve this. We have already solved how much time they need to finish the whole course, right? Leo needs 3 hours and 30 minutes and 20 minutes to finish the whole trail. Juan needs 2 hours and 40 minutes to finish the whole trail. So what is the difference between these 2 hours is how much Leo needs to get a head start before Juan, okay? Because the time that they finish the trail will not change because their speed doesn't change either, right? So 3 hours and 20 minutes minus 2 hours and 40 minutes will be, let's change that back into your fractions. 10 over 3 minus 8 over 3 hours, which is 2 over 3 hours or 40 minutes. Okay, so Leo has to finish the trail. Leo has to get a head start of 40 minutes before Juan so that they finish at the same time. So 2 over 3 should be our hour. So 12 times 2 over 3 is going to be our equation. Okay, so after 3.2 hours, they're gonna reach 40 miles from the beginning. But for Leo, right? But for Juan, he only takes 2 and 40 minutes to get a head start. So algebraically, when Juan reaches that would be after 2 2/3 hour. All right, so that matches our time. All right, So in this lesson, we'll think about how we can use a graph to illustrate the solution to a system of linear equations. Let's look at example 1. Solve a system of equations by graphing. We're going to solve system of equations by graphing. So there are multiple ways to solve a system of equations. First of all, you need to know how to graph them, and graphing will help you solve them. Let's look at the solution of the system of these two equations. Okay, we have y equals negative 2x minus 4, y equals 0.5x plus 6. If you graph them, one is a positive slope, so the second one is red, and one is a negative slope. The first one is the blue line, and they intersect at one point. And using graph, they intersect at exactly -4, 4. So the point of intersection is going to be where both lines have the same x values and the same y values corresponding to each other. Okay, so they both have the point -4, 4 on the line. So -4, 4 is a solution for both equations. That is a solution for the system of equations. Okay, the intersecting point. So let's look at number 1A and B. Try graphing them and see if you can find the intersecting points. Come back when you are ready. Okay, part A. You're gonna graph y equals 1/2 x minus 2 and y equals 3x minus 7. So let's put that in decimals because it's easy to graph this way. That is y equals 1/2 x minus 2. You have a positive slope and your y-intercept starts at -2. Your second line is y equals 3x minus 7. Your y-intercept is -7, and you have a steep slope of 3. Okay, it's going up faster than the first one. And you see there is one intersecting point, and that is exactly 2, -1. Okay, that is 2, -1. That is your solution. 2, -1. They both have the same point. What about part B? Let's draw part B. Okay, your first equation is y equals 2x plus 10. Second equation is y equals -1/4 x plus 1. Okay, so the first one has a y-intercept of 10. It has positive slope, so it's going up from left to right. Your second line has a y-intercept of 1, and it has a negative slope. And they intersect at this point, which is exactly -4, 2. That is your solution. Okay. So how does graphing the lines help solve the system of equations? The intersection point of the two lines can be determined from the graph, and that is your solution for the system of equations. Let's look at the next example, example 2. Graph systems of equations with infinitely many solutions or no solution. There may be cases where you have infinitely many solutions or no solutions. When is the case? By algebra, we looked at when the equation makes sense, every value is true, so it's infinitely many. When it doesn't make sense, like 2 is equal to 4, it doesn't make sense, there is no solution. What does that really mean in graph? What does that mean graphically? So look at part A. What's the solution for the system of equation? You have two different forms of linear equation. What are they? The first one is standard form. Second one is slope-intercept form, where the slope and the y-intercept is changed. So this is actually really not really any form, but Yes, it's close to slope-intercept form. But anyway, so if you graph both of them, they have the same y-intercept, they have the same slope, and they're exactly the same line. All the points are the same. So all the points on this line will be also on this line as well. So they're exactly the same line. And so this is when you have infinitely many solutions. There are many points that they have in common. Okay. What about part B? If you have two parallel lines like this, right? You have a standard form for the second one, and this is not really a form. But if you change both of them to slope-intercept form, they're gonna be the same. Y is equal to 2x plus 6, and this is 2y equals 4x plus 8. But if you divide all of them by 2, you get y is equal to 2x plus 4. Okay, so they're very similar. The slopes are the same, but their y-intercepts are different. What does that mean? They're parallel lines. And if they are parallel, would they ever have an intersecting point? No, all the points are going to be different. There's no intersecting point at all. So there is no solution for these two lines. There is no one point that they have in common. Okay, so then you have a no solution. So let's look at try number 2, A and B. See if they have infinitely many or no solution. Okay, come back when you're ready. Part A, when you change them to slope-intercept form, they will have the same slope but different y-intercepts. And if you graph them, what do you have? They have two parallel lines. Okay, let's graph them to visually see. Okay. Y equals 1/2 x plus 7 and 4x minus 8y equals 12. Okay, there are two parallel lines. They will never intersect. But you know, sometimes when you look at the graph, you're not sure if it's perfectly parallel or they're very slightly not parallel, right? If they're even slightly different slope, right? Like 7/9 and 6/9, they might be close off. And in graph, they might look like they're parallel lines, but they're actually not. So it's always a good idea to double check your answers algebraically. Okay, we're gonna go over this later, but yes, but you can also change this to y-intercept, slope-intercept form. 8y is equal to 4x minus 12, and you divide all of them by 8, and you get 1/2x minus 3/2. Okay, so then you still have the same slope. So this is going to be no solution. Okay, what about part B? Let's graph part B. 3x plus 2y equals 9, and 2/3 y equals 3 minus x. Okay, what do you see? They are exactly the same line. Okay, so they have infinitely many solutions. You can also check by solving them out algebraically. All right. Let's look at example 3. Write a system of equations. We have a word problem here. Manisha and Holly have 14 more days to finish reading the same novel for class. Manisha plans to read 9 pages each day. while Holly plans to read 20 pages each day. Assuming Holly and Manisha both maintain their reading plan, when will Holly catch up with Manisha, who will finish reading the novel first? What's the number of pages read each day represented by the coefficient of the x variable and not the y variable? When you are writing the equation. Manisha has total pages equals 96 pages already read plus 9 pages each day times x days, right? The number of pages read each day is equivalent to the slope because that's how fast they're reading. That's their speed. So that's rise over y, which is the coefficient of the x variable in the slope-intercept form of a line, okay? And Holly reads 20 pages per day, that's her slope. And she already read 6 pages, so that's the y-intercept where she starts with. If you graph them, this is where Holly starts with 6 pages, and then she reads 20 pages per day. And she reads faster, a lot faster than Manisha. Manisha already read 96 pages, so she starts here, 96, but she reads 9 pages per day, so she's slower than Holly. Okay, and they're gonna meet at some point. At some point, Holly's gonna go past her pages, right? And that is their intersecting point. When will Holly catch up? After a little more than 8 days of readings, because X represents how many days, okay? And Y represents the pages. Manisha will have read 96 plus 9 times 8.8182, about 170 pages. And this is when they both have this point in common. And after that, Manisha will have more pages than, well, Holly will have more pages than Holly. I'm sorry. Holly will catch up with Manisha, and Holly will have more pages than Manisha because Manisha reads slower than Holly. Okay, so a little over 8 days would be when Holly will catch up with Manisha. Since the book is 220 pages long, Holly is reading at a faster rate. She will finish reading the novel before Manisha. Okay, so she will catch up before they finish with the book, and Holly will finish the novel faster. All right, let's look at number 3. Suppose Manisha reads 10 pages each day instead. So how will that change the length of time it takes for Holly to catch up with Manisha? Okay, so Manisha, instead of 9 pages per day, she'll have 10. So Manisha's equation changes from 96 plus 9x to 96 plus 10x. Okay, so then let's graph them. This is Manisha's new equation. Y equals 96 plus 10 pages per day. And then Holly was 6, starting from 6 plus 20 pages per day. Okay, do you see that? And they will have an intersecting point. Or here, right here, 9,186. So after 9 days, exactly 9 days, they will have both read 186 pages, and that's when Holly catches up with Manisha. And after that, Holly will have read more pages than Manisha, where Manisha started with the bigger pages, right? So Holly will catch up with Manisha after 9 days. Will Holly still finish the novel first? So novel is how many pages long? 220 pages long. Did she catch up before the novel ends? 186 is less than 220, so yes. 220 is about here, right? So Holly catches up, and then she will go ahead after that and she will finish the book first. Okay. So yes, Holly will finish the book after about 11 days. And what about Manisha? 220 is, where's 220? 220 is here, right? So Holly will finish it after about 11 days. It's closer to 11 than 10, right? Molly will finish it after about 12 days or 13 days, right? After 12 days, she still hasn't finished it, so she has to finish it in the 13th day, right? So Manisha will finish the book after 13 days. So in this case, you always round up for the days, because if you round down, they still haven't finished the book. Okay. Okay, let's look at example 4. Solve a system of equations approximately. Sometimes your answers may not be exactly a whole number of the graph. So it might be very useful to use a graphing tool like Desmos, or if you have a graphing calculator, you could use a graphing calculator as well. Let's try to graph these two equations and figure out a solution. If you use a graphing utility, like the textbook does here, you can see that the intersection point is not exactly a whole number, a nice little whole number, right? So then you have 1.286, maybe that's rounded up, comma, negative 0.429, right? You then check the values of x and y, where the equation for each equation, to see if they really satisfy both equations. Because if they do, then they're a solution. If they don't, they're not. Okay. So when you plug in x and y, and they're both going to be a little bit different. Okay, negative 0.429 is not equal to negative 0.428. Negative 0.429 is not equal to negative 0.43. Right, the solutions by graphing are close to, but not exactly equal to the actual solutions, because they're rounded, they're probably rounded up and they're not exact solutions, right? So they're correct to some decimal places, but it's not an exact solutions. Well, how do you get the exact solutions? You need to solve it algebraically, okay? So how do you solve by algebra instead of graphing? You set the two equations equal to each other. When they have the same point, that means their y values are gonna be the same, x values are gonna be the same. So why don't we set the two equations equal to each other, right? When the two y's are the same number, then 2x minus 3 has to equal to negative 5x plus 6, where x is also the same number, right? So we're going to set them equal to each other and solve for x. It turns out it's 9/7. 9/7 is 1.285714 repeated. So that's why we get this 1.286 in the graphing calculator. If we substitute the fraction into each equation, we have the same solution. And so that is our exact answer. Okay, so in order to find an exact answer when you don't have an exact solution, needs algebra skills. All right, number 4, what solution do you obtain for the system of equations by graphing? What is the exact solution? So by graphing, why don't we graph the 2 lines on decimals? Y equals 5x minus 4 and y equals negative 6x plus 14. Okay. Our intersection point is 1.636, comma 4.182. Okay. 1.626, 636, comma 4.182. Okay, but what is the exact solution? We're gonna solve them out. 5x minus 4 should equal to negative 6x plus 14 when you have the exact same y, and x should represent the same number. So when we solve for this x, when we set them equal to each other, that is our x value of a point. Okay, so we're gonna add 6x on both sides, and we have 11x minus 4 equals 14. We add 4 on both sides. We have 11x is equal to 14 plus 4 is 18. And so x is equal to 18 over 11 if we divide 11 on both sides. Okay. And so when x is equal to 18 over 11, we can figure out y by substituting it to any of these equations. The y values are going to come out the same. Okay, but if you want to double check, of course, you can substitute to both equations and see if your y values are the same. Okay, but they're gonna be similar. They're gonna be the same. So 5 times 18 is 90 over 11. 4 in the same denominator is 44. 4 times 11 is 44 over 11. Okay, 44 over 11 is 4. So then 90 minus 44 would be our answer, which is 46 over 11. Okay, you can also plug into our second equation. You're going to get the same y, 46 over 11. So the exact solution is 18 over 11, comma, because that's our x, and your y value is 46 over 11 when you have 18 over 11. Okay, sometimes it's not a whole number, and it might not be as pretty as whole numbers, but you may get exact solutions by working through the fractions. All right, so this is another way to solve systems of equations. Let's summarize our lesson. Okay, so a system of linear equations may have one solution when they intersect in one point. They may have infinitely many solutions when the 2 lines are exactly the same line because they have infinitely many points overlapping to each other. They may have no solution when they're parallel lines. Okay, so this was lesson 4-1. We'll continue with our next lesson in the next video. Bye.